All right, so these are technically the notes starting for Unit 2. So we're going to start off, since we've talked a little bit about the particulate nature of matter, we're going to talk a little bit about how to classify matter. So when we look at everything in the universe that is matter, and remember matter is everything that has mass and takes up space, we can put it into two large groups, substances and mixtures. Okay? Substances are elements and compounds. And if you read in a textbook, it usually says something like there's a fixed composition. What does that mean? Well, it means basically that if you find a chunk of iron, all of the atoms in the iron are iron atoms. And if you find a sample of water, all of the molecules are going to be the same, and they're all going to be H2O. Okay, so those are pure substances. Mixtures are kind of difficult to describe. The best way I can describe it is they're combinations of two different things where the amounts can differ from place to place. And so I always share that when I was a kid, we always ate cereal for breakfast, and we usually had Raisin Bran. And my parents were very thrifty, and they bought sort of the generic Raisin Bran. And when we went over to my neighbor's house and had their Raisin Bran, they bought the name brand, like Post or Kellogg's. The name brand Raisin Bran has a lot more raisins in ratio to the flakes. It's a different kind of a mixture. They're both made out of raisins and flakes, but the name brand, and that was like, I was kind of like bitter about that for a while because I was like, man, we're not getting enough raisins. So pure substances have a fixed ratio. So when we talk about water, it's not like you can make water and have it be H3O or H2O4. It doesn't work that way. It's a fixed composition. Mixtures, on the other hand, they can have any kind of a ratio, okay? So here's a little table that kind of shows this relationship, how we classify matter. And so we've got matter up here at the top, anything that has mass and takes up space. And it can be broken down into pure substances and mixtures. And then the pure substances can be broken down into elements and compounds. Okay?
Define element. Is that the simplest form of matter?
Yeah.
We'll get there. Just be patient. Yeah, okay. So, three words that students get confused with because the way we use them in everyday life is a little bit different than how we use them in chemistry. The three words are element, compound, and molecule. So when we use these words in chemistry, we mean specific things. So elements are made up of only one kind of atom. So if we look at a picture, a particulate picture, like we've been drawing, and there's only one color of circle, it's an element. Okay? A compound is two or more atoms of different elements that are stuck together. Molecule is kind of a generic word for like anytime you have two particles stuck together, a chemical bond between the particles, it's a molecule. So if I wanted to represent an element, I could draw a dot, or I could draw two of the same dot stuck together, right? If I wanted to model a compound, I would have to draw two dots that were stuck together that were different from each other. Okay. Now, these two, this one and this one, these are both molecules because they have two atoms stuck together. So molecules can be elements or compounds. Elements can exist as single atoms or as molecules. Compounds are always molecules. Okay? So those are just that's some terminology that you should make sure you've kind of got straight in your head. So, like Travis said, the smallest particle of an element is an atom. The smallest piece of matter that you can have that's still an element. The smallest particle of matter that you can have that is still a compound is called a molecule.
Did you hear about Bebop coming to fill your room? I don't know if you...
Wait, what?
Wait. Okay, so elements are represented by symbols. And you may be familiar with the symbols for the elements from the periodic table. The symbol is always an uppercase letter or an uppercase letter followed by a lowercase letter. It's never two uppercase letters, never two lowercase letters. It's either one uppercase or an uppercase and then a lowercase. These are symbols, okay? So everyone around the world, no matter what language you you speak, you recognize this is sodium. It doesn't matter, okay? If you speak Russian, if you speak Chinese, if you speak French, that's sodium, okay? So these are symbols, not abbreviations. We've got to keep that in mind. Compounds have formulas. And so NaCl is a formula, okay? Do you remember when you were a little kid and you were first learning how to spell words? And sometimes you didn't always put your letters together right? Oh, please, I'm sure you do.
Not yet. I'm still learning.
Still learning. Okay, well.
It's always good to keep learning.
Yes, it is. Okay, so this would be an example of a symbol. This would be a sample of a formula, okay? And so when we write formulas, we want to write our symbols correctly, just like you would want to write your alphabet correctly. And we want to write them close together to show that they are together, okay? Now, elements have symbols and compounds have formulas. But sometimes there are formulas that look like this. Okay, so that's Cl2. What that means is that I have two chlorine atoms stuck to each other. Okay, it's an element. Oh, it's right underneath that thing, isn't it?
Chloride.
It would be chlorine.
Chlorine.
Yeah. Okay. So that's an element, and it's a molecule. And we call that Cl2 a formula. Okay. This one is a formula. It's a molecule, and it's a compound. Okay, because it's got two different elements together. And this last one is a symbol and an element, and it represents one atom of the element. Okay? So in a lot of ways, this first quarter is like a foreign language. You're going to be learning the language of chemistry. Okay? So, in nature, there are 118 elements that we know about. The last, 116 through 118, we've just discovered recently. Okay, and we'll talk later about how we go about discovering new elements. Only 93 of our elements actually occur in nature. The other ones we have synthesized in a lab. Compounds, there are millions and millions of compounds, and even more molecules. Everything around you is made up of some kind of a mixture or a mixture of compounds and elements. There are lots of compounds that we have not discovered yet, and that's one of the concerns about the fact that the Amazon rainforest is disappearing. They have found some really interesting plants that they never knew about before, and they found chemicals in those plants that they think might make medicines. So, the cure for cancer might be growing in the rainforest right now. And if we harvest all the plants and kill them all, we could lose out on that. So it's really important for us to preserve that area so that we can find out those things. They still don't know. People have smoked tobacco for hundreds of years. I don't think that they have yet identified everything that's produced when you burn tobacco. They don't know all of the chemicals that are produced. They're still figuring that out because there are so many things that can happen. All right, so here's some examples. Elements. We've got our uppercase letters or uppercase, lowercase. We've got our molecules that are elements like H2 and O2. Got our compounds that have more than one chemical symbol in them. And then we've got our molecules. And remember, molecules are just sort of a generic name for any time you've got two or more atoms that are bonded together or stuck together. H2O.
NH3.
So H2O is water. NaCl is sodium chloride, which is table salt. NH3 is ammonia, which is like in window cleaner. And NaHCO3 is baking soda. And we will learn when we look at the periodic table, when we learn about the periodic table, there are some elements that like to be in a pair. They never like to go like one atom. So there are certain elements like we see here, hydrogen and oxygen, also chlorine. They don't like to, in nature, they are not found as individual elements. They're either in a compound or they're paired up with another element of the same kind, another atom of the same kind. Okay, so here's a little picture that might help when you're thinking about things like those particle diagrams in ChemThink. So notice at the top with the elements here, the way I can tell it's a pure substance is if I start circling the individual particles, all of the individual particles look exactly the same. Same thing here. Every particle looks exactly the same. Down here with the compound, every particle looks exactly the same. That makes it a pure substance. Okay? If I start circling particles and they don't look the same, I have a mixture. Okay?